this we get from our foodstuffs. Well, we've talked about it in relationship to glucose because that's the only molecule that can carry out glycolysis. But that does not mean we didn't take in other foodstuffs. The way the body, like we've said before, wants to get and use energy, okay, wants to use sugars first, lipids second. We use lipids to make ATP. They simply enter the process at a different point. Those triglycerides, the fats, okay, they'll get broken down. If you guys remember, they're broken down into the little fatty acids, the little, because there are 3 of them, okay? Those fatty acids are taken up by the cell. If they're used for energy, they enter directly into the citric acid cycle. They didn't have to go through glycolysis because they're not glucose, okay? They simply go into the process at the point of the Krebs cycle. That Krebs cycle continues its process. We get electrons. We go to the electron transport chain. We produce energy. So we can get energy from the fatty acids. Now, some of it is turned into ketone bodies. Now, a lot of times you might hear about that in relationship, like some diets, okay? Like the keto, is it the keto diet or something? Okay. And what's the basis of that? Do you happen to know? You're basing it on a lot of protein. And the low carb, okay? They're eating like a lot of the meats, a lot of cheeses, stuff like that, very few carbs. And the hope is that those ketones that get formed will go into areas like our skeletal muscle and get used for energy rather than going into the fat cells and getting stored and gaining weight. Okay? Some people, it's been a really good diet for them. Okay? I've met people who have lost a ton of weight on this type of diet. It is a delicate balance because they have to make sure that they do use that energy, because sometimes when these ketones, if they build up in the body and they make their way, especially like trying to be gotten rid of by the body, you can go into ketosis, okay, which can affect the kidneys. So it's a delicate balance that you have to do, okay? So it is a way, though, however, we're using fats. Now, if we go into using proteins to make energy, we don't want to do that, okay? We really want our energy to come from carbs and fats, okay? If we begin to make energy from proteins, chances are, because when we take in proteins and the body breaks them down into the amino acids, those amino acids immediately make their way into a cell to be used to make a protein. Because the only thing a cell can make is a protein. So those amino acids need to get to the cells so the cells can use them. However, if we do use these for energy, we take those amino acids, they undergo this oxidative deamination, which is a changing around of their chemical compounds. Usually, byproducts are the ammonia, which the body has to get rid of, usually by way of the kidneys. However, like I said, if you're making energy this way, chances are things are not going good in your body anyway, okay? This will probably build up and become toxic in your system because your kidneys are probably not functioning correctly. We get keto acids as a byproduct, and then this means we don't have anything available in the body to use for making proteins. So that means the biggest place where they're pretty much going to pull the products from is your skeletal muscle. And like I've said before, this ends up creating the situation where people end up being like skin and bones. I'm sure you've seen pictures of where there might be a famine, and you see the pictures of the people who are going through the famine, and they tend to be very skin and bone throughout their legs and arms and so forth, but their belly is really big. This is because that's ascites. It's a buildup of fluids that their body can't get rid of. Okay, they don't have any muscle to have energy. It's just terrible what happens. Usually, people who have cancer, when they get to the last stages of cancer, this is what their body's doing. Their body is taking these proteins from their skeletal muscle, breaking it down, using it for the energy. And that's why you see them waste away. Other diseases like COPD, people who go into extreme COPD, you begin to see them wasting away because their body is demanding the energy. Like people who have COPD, have you ever known somebody who's got this? And they might have to have that oxygen, and even if they have to take at their house or whatever that's making the oxygen. Okay, you'll see that as the disease progresses, they begin to get thinner because the body needs so much ATP for them to simply breathe that it's beginning to break down proteins for energy. It's just, but anyway, what happens is, depending upon the amino acid that's used, it simply enters at a different point of this Krebs cycle. It continues the process, and you go on to making the ATP for the electron transport chain.
How come, when they say, after you lift weights, you want to take, you need, extra protein, like a protein shake. So, is that, you're not using it for energy, or you're just using it to rebuild, the cells? Or?
The protein shakes, like you're thinking about for that, first of all, it kind of depends on what type of weightlifting are they doing, okay? Are they doing weightlifting to simply tone, okay, which that means they're not wanting to get bigger, okay? A lot of times, people who are going to do those protein shakes, they're going to be the ones who are vigorously using the muscle. So think about the people who are building up, to be they're probably needing that protein shake, okay? Because the amount of muscle, and you probably hear it talked about in terms of they're breaking it down to build it back up, okay? Sort of, yeah, okay? But what you'll learn is we learn about skeletal muscle. For it to work, we have these protein fibers, okay? They're called actin and myosin.
Yeah.
And so those actin and myosin have to have the ability to do this. And when people are building muscle, that's what they're building. They're building more actin and myosin. So if they take the protein shake, the hope is that it's providing the material for that cell to make more actin and myosin.
You mean the sliding filament theory?
Mm-hmm. Yep. But take a break. Be back at 9:30.